Namaste and Vanakkam also. Okay, so we'll begin with an overview of what we discussed yesterday. Will any one of you please share your overview? Please go ahead.
So yesterday we talked about maintenance performance measures metrics.
Yes.
Uh, we here we are trying to develop. Here we are talking about the bridge between maintenance management and management. So
Maintenance. Yeah. Okay. Actually, also maintenance engineering and maintenance management, both.
okay, sir.
Yeah. Go ahead.
So it's a bridge that we are discussing. We talked about maintenance performance,
Yes.
in which we first talked about emergency failure frequency ratio.
Yes.
Uh, which is number of emergency failures per operating time, or it could be number of failures
Number
per
of
number of emergency failure per number of total failures,
yes.
because emergency failures could be classified.
Hmm.
And
Correct.
then we talked about emergency failure intensity ratio, where
Yes.
which is downtime from emergency failure per operating time.
Correct.
Then trend in downtime, which is weekly or monthly downtime plots
Hmm.
by equipment type.
Yeah.
Here we talked about why plots are necessary
Hmm.
to get because we get pattern from plot, and
Yes.
then
Yeah.
a trend in number of maintenance manpower,
Yeah.
daily or weekly plots again for crew workers,
Yes.
and then material cost per repairman,
Yes. Correct.
which is
So those
yeah.
are the five measures we have talked of. These are individual measures. Okay. You may recall that I had mentioned about Sohei Hibi's book, Sohei Hibi's book, Japanese author, How to Measure Maintenance Performance. That book was published by the Asian Productivity Organization. And personally, I feel that's a very, very useful book for understanding maintenance performance measurement. Okay. I also mentioned this point, Aryaman, about always having a period in mind. So when we are measuring maintenance performance, have a period in mind, whatever it is, a week, a fortnight, a month, a quarter of 3 months, a half year, or a year. Okay. Why? Because you can also compare the data across the periods to indicate the trends in maintenance performance, overall maintenance performance, whether the maintenance performance is improving or is stabilized at a very high quality level or is degrading and so on. Okay. So the period is very important. Okay. So that's the other point. So thank you for that summary. So we will just start the discussions today. Yeah, just getting the slides shared with you. So those were the five measures that we discussed yesterday: emergency failure frequency ratio, emergency failure intensity ratio, the trends in the downtime, either bar charts or line plots, as will be applicable depending on the nature of the data, the trend in the number of maintenance manpower, the crew. Okay. This can be classified even according to the nature of the crew: electrical, lubrication and oiling, alignment crew, mechanical, civil, plumbing, and so on. Okay. And the fifth one is material cost per repair person. Okay. I said repair person because it's quite likely that we will have women coming into the maintenance workforce. I don't see, I'm sure it is already there in a few plants, not widespread, but it could become more common as the years roll by. So then material cost per repair man, total repair material cost by total repair manpower, and then the planned work ratio. This is something which I don't think we discussed this yesterday. Am I right? Did we discuss planned work ratio yesterday?
No, sir.
No,
No,
sir.
sir.
Yeah. So good. So we discussed five, I remember. So the sixth one is planned work ratio. So as you can see, the definition is it's the man hours of planned work See, remember, we do maintenance planning. So the maintenance planning will have one of the settings as man hours of planned work. How many hours of planned work? This we will know because the planned work will consist of specific maintenance operations, which we have discussed earlier. Can anybody recall what were the specific maintenance operations that we do in preventive maintenance or planned maintenance? Do you recall, please? I'll give you a clue, starting with basic observation. There were a few other things we discussed. You can please look at your notes and try to respond. Yeah. See, this feedback and feed forward of discussions is very important in our learning, you know. It helps us reinforce our learning. So please
Inner
go.
inspection.
Rishabh, yeah, planned inspection. Yeah.
Inner inspection.
Correct. Inspection. Anything else, Rishabh? There are a few things which involve active maintenance work also.
Intervention.
What are the interventions, Mohan Raj? What interventions did we talk about? Some simple ones I'm asking. Do you recall we talked about things like alignment, checking gaps, monitoring for heat, smell, etc. Do you recall that?
Yes.
Also oiling and greasing, you know, and sometimes tightening of bolts, etc. All these go into some planned work. So you know for a period, for a week, you know in the coming week, what are the maintenance jobs at hand. That is independent of the job orders that come to you. Job orders come from outside. You can have a system of internally generated job orders also from the maintenance department point of view. You know, you can also internally generate job orders. Please do not forget, yesterday I had also talked about the value of documentation. Please do not forget that at all. You cannot handle it in your mind and your memory. It's not feasible. So you'll have to do a lot of heavy documentation as the work goes on, because that's what will actually help you gain control. So you've understood planned work, because you can plan for a week even using internally generated job orders independent of the external calls for maintenance. Okay, so you can estimate the man hours. So that's the numerator by total man hours of maintenance work during that period. Now, in what way will total man hours be larger than planned work? What is it that will happen in maintenance where the total man hours of maintenance work will be greater than the man hours of planned work? Have you understood my question?
Sir, if the frequency of downtime is high.
Not a bad answer, but it will be nice if you can go with a more specific answer. In a period of a week, you'll have, at the end of the week, you can calculate the total man hours spent by the maintenance crew. Correct? So that will definitely be greater than or equal to the man hours of planned work. So if it's greater than, what are the components of total man hours of maintenance work which are different from the planned work? The answer is on that slide itself. Yeah? Do you recall I told you about external job orders?
Yes, sir.
So external job orders, are they planned work or unplanned work?
Unplanned.
Yeah, absolutely. Because somebody, and do you agree, I said the answer is on the slide. Do you agree emergency failures will be one class of unplanned work? And they may consume a lot of time, in fact, much beyond your planned work. And in some instances, emergency failures can even intrude into your planned work. forcing you to postpone your planned work. Okay, that depends on the nature of the emergency failure. So that is why the denominator is greater than or equal to the planned work. Is that clear?
Yes, sir.
Okay. So let's
Sir,
move up.
so the denominator would be the sum of the planned work and the
And
unplanned
the
work.
unplanned work. Correct.
Okay.
Yeah. Good. Yeah, come on.
Hello, sir.
Yes, please.
So the ideal ratio should be 1 for planned.
Yeah, ideally, yes, I may agree with you. Ideally, yes, you don't want any unplanned work. Your planned work is so good that you don't get unplanned work. That's not a bad argument. That's very interesting. But do you think that will really happen in reality?
No, sir.
Very, very rare, because see, there are many things which we cannot predict. And please also understand, there may be instruments involving electronic components which are known to fail suddenly. See, in the case of mechanical parts and components, you know, there is wear and tear, and you can sort of, if you're quite experienced, you will have a good idea of the wear and tear, and the anticipation of failure will be quite good. You know, you'll be quite accurate in anticipating failure, because you'll be able to judge the wear and tear, and there are many things that will happen. You know, for example, noise is a good indicator of some wear and tear. You'll get rattling noise in equipment and so on. Okay, this happens even in your scooter or your car. After a few years, you get door rattle noise and other rattling noise will come. So you know something has to be tightened or aligned and so on. Whereas electronic components could fail suddenly. You know, okay, one can say, sir, maybe they are going through some electromagnetic cycles, but somehow most people may not be tuned. At least I feel if somebody is able to anticipate the failure of electronic components pretty accurately, they must be true masters of that technology. You know, I'm not aware of such people though, and most books on maintenance also suggest that electronic components fail suddenly sometimes. Okay, they don't have a pattern. Okay, not the kind of pattern which we drew in the first or second lecture. Remember that decreasing pattern and then sudden drop of equipment full functional availability. Okay, so the seventh one, planned work enforcement ratio. Okay, this is man hours of planned work actually done divided by total man hours of planned work. Now, do you agree that even the planned work which is actually done need not be exactly equal to the total man hours of planned work? Do you agree?
Yes, sir.
Yeah. Can you think of situations where man hours of planned work could be greater than the total man hours of planned work? I mean, I'm talking of a situation which is funny. You originally did some plan for the week, and at the end of the week, you find that the man hours of planned work is greater than that original estimate of planned work. Not the denominator here. The denominator here includes the numerator. Okay, that's why I'm giving you this specific instance where at the beginning of the week you do some planning and estimate the man hours. Okay, but at the end of the week you find that actually you've crossed the planned work, actual work done. Okay. Can you tell me how that could happen?
So when we plan work, underestimating our efficiency.
Yeah, that is one. And of course, don't forget, when you actually work this ratio, the total man hours of planned work will include the numerator, including if any inefficient operations, etc. Because you will do, you'll work out this planned work enforcement ratio at the end of the period, whether it's a week or a fortnight or a month and so on. Is that clear? So the denominator will include the numerator. So it will be greater than or equal to the numerator. Okay, I was just trying to point to something that can go wrong from the original estimate of planned work. It can also be amount of planned work done divided by total amount of planned work. It need not be only man hours actually. Okay, it need not only be man hours. There can be some other equivalent of the planned work. Especially when you go to project management literature, please do understand that annual maintenance turnarounds in several plants, especially in continuous processing plants, chemical plants, refineries, etc., industrial chemicals and so on. They may wish to do what is called a shutdown annual maintenance turnaround. So they'll shut down the plant for about a week and do pakka maintenance, and there it is treated as a major project actually. And when you get into project management literature, there is a nice concept. You can just make note of it so that you remember this as an idea. There is a concept of earned value, EARNED, earned value, okay, which gives you an idea of how much of work has been done in a project at a particular point of time after the commencement of the project. Okay, so annual maintenance turnarounds are fairly large and intensive projects, because you'll have a lot of maintenance team. You can imagine a large refinery. Just imagine how many maintenance teams will be working on the annual maintenance turnaround. So many equipment will be there. Cracking units, distillation, so many heat exchangers, water cooling units, huge water cooling and so on. You would have seen those towers, many places. This is a phenomenal amount of maintenance work. So you'll have a lot of teams going on that effort, and it's a huge project. So that's why the concept of earned value will come in. And that is the reason I was pointing out that it need not be only man hours. Man hours is easy to log in, especially if your documentation is correct. Okay, it can be in rupee terms also if you wish to have it that way. That's why I said or amount of planned work done by total amount of planned work. Okay, then you have something called oil consumption ratio. You'll see energy and oil consumption are very strong indicators of the status of maintenance. Do you agree? Do you agree that energy consumption and oil consumption could indicate, indirectly at least, about the maintenance status?
Yes, sir.
Sir.
I'll give you a simple example. If you notice that in the plant the energy consumption is significantly higher for the same equipment, what is an inference that you can draw?
It needs maintenance.
Yeah, that's a general inference, correct. Anything
So
else?
there may be friction in the parts.
Yes, absolutely. That's more specific. That's correct. Ariman's answer was correct that you need more maintenance. I was trying to get at a specific answer. So it means that there's somewhere the energy consumption, there's greater amount of current being drawn by all the equipment, isn't it? So the greater power is being drawn for the same voltage drop, across the equipment, which means there's something wrong with the alignments, with the friction, wear and tear, etc. So similarly for oil consumption also. Okay, so you will always find in maintenance performance evaluation there'll be something to do with oil, there'll be something to do with energy. Okay, so oil consumption ratio, you can see this value of oil consumed in rupees, which per period. You know what is the value of oil consumed, okay, per period, by total power consumption. That is, per kilowatt hour of power, how much of oil are you consuming? It's a very good indicator. Okay, or you can have per operating time in minutes, how much of oil is consumed. Okay, so you can calculate this over a period, and that gives you the oil consumption ratio. I hope this is clear. Now you can even better appreciate why I said these performance measures form the bridge between the engineering and the management. I hope you are able to appreciate that. Okay, yeah. So then the ninth measure, lubricant failure ratio. So number of lube failures which you can notice in a period, say a month, by total number of all failures. So you'll have various types of failures. You log them all in your documentation and find out how many of what proportion is constituted by lube failures. Okay, so that's called lube failure ratio. Now that also indicates the maintenance status. I hope you're clear why it can be used to indicate maintenance status. Okay, because lubrication, is lubrication a planned operation or not? Maintenance operation. Do you agree?
Plant.
Yeah,
Plan.
lubrication is a planned, usually a planned maintenance operation. So loop failures means something has gone wrong, obviously. So that's why we take this ratio. By the way, in many plants these are very useful, and even in hospitals in some cases, because hospitals will use a lot of air conditioning equipment, motors, compressors, etc. And remember, those will be huge units, especially in a large hospital. You can very well imagine the amount of air conditioning that will go into the hospital. So you are dealing with very large equipment then, so this loop failures can be critical, and that's why some people adopt a different philosophy. Some people prefer a centralized facility for air conditioning, whereas I have come across some hospitals where they sort of classify the hospitals into zones and do differentiated air conditioning. They don't do a one size fits all. And even in the centralized air conditioning, it's like in many hotel rooms, you have individual controls in enclosed spaces within the hospital. So suppose I am a patient in a hospital, I am giving a simplest example, I can control the temperature in my room, even in a centralized facility, okay. It is something like that, okay. So you must be very careful about loop failure, okay. And remember, loop failure can happen in so many locations, literally hundreds of locations in a large hospital. So that's why you have to be very, very careful, because lubrication is always local. I have not come across centralized lubrication, at least I don't know. In case you come to know, please do inform me. I have not come across centralized lubrication for a plant. There can be a certain amount of centralized coolant facility, that I have seen for some machines. They have a centralized coolant facility, not for all machines. Lubrication I have not come across, but I'll be very happy to learn if there is centralized lubrication in some plants, okay. Then the 10th performance measure is maintenance cost per unit of product or operation. This is very interesting because we are now linking the maintenance effort with the production effort, and that's very useful. Can you tell me which concept actually does that linking? Which concept have we discussed so far which does that linking? I'm not talking of the formula on the slide. There is a concept which is very important. Do you recall? We have discussed this often. I'll give you a clue. What is the primary objective of maintenance?
To minimize downtime.
Very good. The converse?
Maximize availability.
Absolutely. Now, do you agree availability has a direct impact on production?
Yes, sir.
Now you see. So this is the 10th measure, maintenance cost per unit of product or operation can be determined by total maintenance cost during the period, which okay, divided by the production volume, which is expressed in either units of production or rupee terms. Rupee terms is a little better because if you are looking at a multi-product kind of a company, of course, I am not taking only hospitals as an example. I am trying to give you examples in discrete manufacturing and continuous manufacturing. So if you take discrete manufacturing, which means the manufacturing produces discrete products, like chairs or maybe carburetors or whatever it is, okay, discrete physical products. So there you can get into rupee terms because a plant may actually produce a variety of products. So then you may have to do maintenance cost product wise and rather than production volume units, because the units may have to be segregated then. If there are multiple types of products, you may have to classify the maintenance cost according to the type of product also, which you can do if your documentation is pakka. You can do that, okay. So rupees will sort of neutralize that. So you can look at what is your total maintenance cost in rupees per rupee of production. See, here there is an assumption. You can always look at this coupled with something else. If you look at production maintenance cost for low rupee from sales point of view, I'm just giving you a situation where you can make a comparison. Suppose you have the total maintenance cost. Now that's fixed for a period, and on the denominator you are using the production volume expressed in rupee terms. Number one. Number two, let's say somebody says, why should we put it in rupee terms and production volume? Why should we indicate production volume in rupee terms? And somebody says, why not in sales revenue terms? What do you think will change in your judgment of maintenance effectiveness? I hope my question is clear. Situation 1, denominator is production volume in rupees. Situation 2, denominator is sales revenues in rupees. Numerator remains the same. How will your managerial judgment change vis-a-vis or in regards to the maintenance effectiveness?
This would include two factor, one of maintenance and other would be sales. So
No,
there would be
that is on the
combination.
denominator, Aryaman. The maintenance is going to be the same on the numerator, no, Aryaman. The numerator is going to remain the same. I'm trying to give you two situations with two different denominators. Production volume in rupees and sales revenues in rupees. What is the subtle difference between the two?
So this particular factor would decrease for sales revenue case.
Yeah, correct, but why?
Because the
Are you
cost
sure
of
it is? Are you sure it will decrease?
Sir, I was thinking like the cost of production of any product is smaller than the amount you make.
That is normally correct because you are looking at cost plus pricing. By the way, Avinash, thanks for bringing that point. If you go into marketing theory, since we are not doing all those things, marketing, finance, etc., pricing is one of the very critical aspects in marketing. Product, price, place, promotion, and so on, you know. So people will talk of that. In fact, some Indian author even added pehchan. You understand what that means? Who do you know, etc. You know, product, price, place, promotion, pehchan, you know. So, but that's okay. So pricing is a very important thing. Avinash, I'm happy that you brought that in. But all I'm saying is, can we make a safe assumption that production volume in rupees will be lesser than sales revenues in rupees?
No, sir, it's not. It will not be a hard assumption. Like
yeah, very good, very good. What could go wrong, Avinash? What could go wrong?
For example, sir, the distribution cost may be higher.
Yeah, that is correct. But correspondingly, your sales revenues will also account for the distribution costs, Avinash, isn't it? See, suppose we are managers, suppose we are marketing managers at a steady state market, in a steady state market where the market is stabilized in our judgment, don't you agree that we will have factored in the other costs into the final price of the product? Correct or not? What do you feel? As marketing managers, wouldn't we like to have a profit coming from after accounting for all the costs? Went, huh? Oh my God. Are you guys connected, please?
Yes, sir.
Yes, sir.
I think the connection went for a moment. So I hope my question is clear. I would like you to respond, please. Do you agree if we are marketing managers, eventually we would like to have pricing or unit pricing such that our total sales revenues will be greater than our total costs of production, distribution, overheads, vagera, vagera?
Yes, sir.
Naturally. I mean, that's what we would like to have. But can you think of a situation where the production volume in rupees is greater than the sales revenues?
So
over a
when
period. Over a period.
so when a defective product has been manufactured.
Okay, you're thinking on that side. Okay, defective product. Okay, you're talking of sales returns, etc. Well, that's a correct answer, But remember, Aryaman, if returns on after sales are so much, it really hurts the companies. I was looking at something else. Aryaman, is it important or is it actually possible always to sell everything that you produce?
No, sir.
No. So let's imagine a situation. Let's say we are talking of companies like Ashok Leyland or Tata Motors, which manufacture trucks, or even Eicher Motors. They're truck manufacturing companies, okay, trucks, and they manufacture the base for lorries, etc. Okay, I'm just giving an example because these are great Indian companies. I mean, they're doing, I believe they're doing well overall, and we should be proud of these companies in India. Do you know that there are situations where there's a market glut and all their vehicles will be sitting in the yard without being sold? I'm sure you would have heard of these situations. I think it happened sometime during the last 2 years also. The vehicles are just sitting there. They've been produced, but they're not being taken off the yard. This can happen with in the automobile industry, okay, and even in some other industries. So in that case, do you agree sales revenues is likely to be lower than your production volume in rupees in a period? Do you agree?
Yes, sir.
So remember, when you're a manager, it's important for you to look at all these aspects, because I'm not being absolutely comprehensive. I'm pointing some directions for you to think. That is what I'm trying to do. Okay, you really need a checklist to look at all the possible combinations. Okay, we're not working with checklists here. So have you understood this 10th measure, maintenance cost per unit of product or operation?
Yes, sir. Can we say before achieving break-even point, total cost will be greater than total sales?
Total maintenance cost. Are you saying total maintenance cost?
Yes, sir.
Yeah. In fact, the answer was in your question. If you're considering before break-even point, may I presume that all of you know what is break-even point?
Yes, sir.
Hey guys, please respond.
No,
All
sir.
of you know what is break-even point?
No, sir.
Okay, then we will discuss this sometime later. But for now, just make a note. Arvind, just make a note. BEP, break-even point. Cost volume profit analysis, CVP. Okay, so we'll have to discuss all these things. Maybe we'll do that sometime later. But there's something called break-even point where your revenues exceed the costs from that point onwards. Okay, imagine maybe I'll use the board now. Can we shift to the board for a minute? Yeah. Okay, so you have something called fixed cost, and there's something called variable cost, which goes like this. Okay, now I'm just giving you an example of fixed cost. Let us say my lecture is being monetized. Are you understanding? Let's say my lecture is being monetized, and let's say I'm being paid. I'm just giving you an example, an illustration. You need not take it numerically very seriously. Let's say I'm being paid 10,000 bucks for 1 hour of lecture. Okay, well, many teachers would wish that. Okay, so let's say we're being paid 10,000 bucks for 1 hour. Okay, now is my payment dependent on the number of students?
No, sir.
Obviously not. Now suppose I have a scheme whereby in elective courses, I'm just imagining, not in core courses, in elective courses, a teacher is paid, let us say 10,000 rupees per hour of elective, if and only if there are more than 10 students in the class, and for every additional student, the teacher will be paid 1,000 rupees more. Have you understood the concept? So this fixed cost for the institution to pay the teacher is 10,000, and then for every additional student I get 1,000 rupees more. So that's the thing which I use here as volume. The volume is the number of students in the example that I gave you. Do you agree?
Yes, sir.
Okay. Now let's take another situation where the institution tells the teacher, for your course we don't have a fixed cost. If you attract students, we will pay you. No fixed, no base. It's your job to attract students. I'm just giving you a hypothetical situation. Okay. And this institution says that for every student you attract, I will pay you 2,000 rupees. Now remember, 2,000 rupees slope is higher than the 1,000 rupees slope. Do you agree?
Yes, sir.
This is 1,000 rupees slope. So 2,000 rupees slope will be something like this. So I'll just mark it here, 2,000 rupees per student is 1,000 rupees per student. I'm just taking a hypothetical example. Now this point presents this number of students here. It presents the break-even point for the teacher. Do you agree? Because now what does it mean? If the number of students is greater than this number, which model will I choose as a teacher?
2001.
2000.
2000 wala, because it's higher. If this number of students is below this point, break-even point, for me, do you agree the 1000 model is better for me?
Yes, sir.
Yes, sir.
Yeah. So are you having a rough idea of break-even point?
Yes, sir.
Okay. Incidentally, you can do a break-even point analysis with kilometers of a car run and a diesel car and a petrol car. Are you able to understand what I'm saying?
Yes, sir.
Yes, sir.
Okay. So you can do the costing accordingly and then check after how many kilometers the diesel car will be superior to the petrol car. Okay. Something like that. You can do these kind of analysis in break-even point. So I'm just giving you a very quick overview. Okay. So that's the idea. So that's what was being mentioned by about break-even point. Okay. So is this clear? Now naturally, when you are below the break-even point, do you agree your costs are greater than your revenues in general?
Yes, sir.
Yeah, I mean, I gave you a simple example. You can adapt that example to a cost and revenue situation. Okay, is this clear?
Yes, sir.
Okay, so that's what was being referred to. Yeah, that the point is certainly correct. I mean, one would ordinarily expect the total cost to be lesser than the total revenue. I mean, sorry, greater than the total revenues before the break-even point. And the total cost will obviously include the maintenance cost, obviously, in a plant. Okay, so that is the whole idea. So I hope you're clear. Can we go back to the slide, please? Yeah. So that's the 10th one, maintenance cost per unit of product or operation. That is total maintenance cost in rupees by production volume in units or rupees. I advised you to take rupees in the denominator. Units can also be done and you can do it unit wise. That is a production type, production or product type wise. Or is a total maintenance cost per process, depending on whether you're doing it on a process basis and operational volume per process. Both are okay. The first one is more common, that's what I understand. So next slide, take the 11th one, maintenance cost per operating time. Now this is the per equipment operating time basically. So this is the total maintenance cost by equipment operating time in minutes. Now do you agree we will have logged in equipment operating time per equipment?
Yes, sir.
In your documentation you will keep that. For every equipment you will log the product, usually the production staff will write down the running time, you know, of the equipment. In any case, you can have enough energy data also to tell you. There will be energy meters connected with the machine, and from them you can sort of estimate how long the equipment has been running, you know. And that's why earlier we talked of energy consumption and the differences in energy consumption for the same equipment for the same duration. You will then judge whether the maintenance is required or not. That's what we had discussed earlier. So for an equipment, for a given equipment over a given period, you can calculate the total maintenance cost. Please note, for a given period and a given equipment for which the operating time is known, you would have documented the maintenance cost for that equipment also. So please understand, maintenance cost, the total maintenance cost for the entire plant is a sum of all the maintenance costs across the equipment and the facilities, utilities, etc. So on an equipment basis, you can judge the total maintenance cost per operating time. So this is to tell you equipment wise how effective the maintenance is. Is this clear? Hello?
Yes.
Yeah, fine. So we come to the 12th performance measure now. Maintenance cost per kilowatt hour of power consumption is something similar to the oil consumption. In the numerator now we have total maintenance cost for a period by the total power consumption in the plant. Okay. Now we use total power consumption because it is an indicator of maintenance even for things like lighting, etc. See, please understand, in a plant you will have the actual machines which are consuming power, you will have many other infrastructure facilities that are consuming power, lighting, air conditioning, sometimes water motors, pumps, etc. They will all consume some power. So there are many things that will be consuming power, isn't it? Electrical power. So you take all of that in the denominator and take the total maintenance cost. As I told you in the previous one, you can even use it equipment wise. I hope you can understand how to adapt this 12th measure even to the level of an equipment. You can calculate this maintenance cost, okay, per kilowatt hour of power consumption. So it's very useful from that point of view. Then the 13th one is maintenance cost per rupee of production cost. Please understand, we have now moved away from production volume in units or rupees to production cost. Okay. In fact, in costing theory, if you study costing theory, I had the opportunity to go up to my inter in the Institution of Cost and Works Accountants exam. I didn't follow up much later. This I'm taking you back many years. Okay, many years ago. You study something about cost. You talk of manpower cost, you talk material cost, overheads, allocation, apportionment, all that stuff we will be doing. Okay. So there is something called total production cost, okay, typically constituted by manpower cost and your material cost, etc. Okay. So when you take the total production cost and in the denominator and use the total maintenance cost in the numerator, you get the proportion of maintenance cost in the total production cost. Okay. As a ratio, at least you can get that done. Okay. So it also gives you a comparative figure for judging maintenance effectiveness. Okay. Then the 14th measure, maintenance cost per rupee of equipment value. This is also very interesting. Okay, please understand, equipment value will change with time. It's not that at time t is equal to 0, you have all the damn equipment in the shop floor and then you start counting. It's not like that. Equipment will come in, equipment will go. I mean, so many things can happen. So you have to have a dynamic system of costing, So total maintenance cost by equipment acquisition cost. Okay. So this is also very interesting because there are many interesting topics that come in here when you talk of maintenance cost per rupee of equipment value. Because let's say we've got an equipment on 1st April of a particular year. I'm taking 1st April because that's the start of the financial year. Okay. Then let's say in the month of April, you've calculated the maintenance cost. You make an assumption that the equipment value remains the same on 30th of April. So you can calculate the total maintenance cost by the equipment acquisition cost, which is the total cost of the equipment plus the transportation, installation, all that stuff will go into the denominator. After all, you will pay for the installation also, assuming you have separate payments, you know. Now, let us say I am coming to 31st March of the next year. From a finance point of view, instinctively, do you feel the denominator is going to be the same?
Yes, sir.
Yes, sir.
Are you sure? It's not a right answer. You would have come across this term depreciation. Have you come across this term or not?
Yes, sir.
Depreciation. And there are standard depreciation rates for different products. You know, for a computer, depreciation rate could be very high. For a building, civil construction, it could be relatively much lower. So it depends on the equipment, isn't it? For a lathe, or for even a what you call an automated CNC machine, the depreciation rate would be there. Please understand, depreciation is the notional reduction in value of the equipment after a given period, typically a year. Okay. See, I'll give you an example. Suppose you buy a mobile phone today. If you want to exchange, let's say the cost of your mobile phone is 15,000 rupees today, 15,000. Now next year a new model comes and you want to exchange the phone. What is the likely value you will get from the reseller? I mean from the seller, not reseller, I'm sorry. From the seller, what is the value you're likely to get for your old mobile phone in exchange of the new one?
At most 7,000.
You'll be very lucky, Arvind. You know, I still recall, I'm taking you back about 3 years. I had a Sony Z5. It was a very good phone actually, but there was some minor problem, and I was the reliability suffered, you know. I said, okay, it's a good phone actually, excellent camera, and it was damn good. I said, okay, I'm going to exchange. So I took one of my friends and went to the mobile shop, and my friend told me, LSG sir, you please buy HTC. He said somebody in his family also has, they're very happy. I said fine, I bought a HTC, I think it was 628 or something, that model, I don't recall the model. So I exchanged the phone, and that person, he checked up, everything was working. I mean, there was no serious issue with the Sony phone, very minor. So he checked up, and I asked him, how much will you take? And I had bought that Sony phone just about a year before, you know. I think I bought it in 2015. So I think the exchange was being made in 2016, I think, okay, just about a year later. And maybe my dates are a little teda, please forgive me for that. The man at the counter told me, sir, 1,500 bucks. I said, what on earth are you talking about? 1,500 bucks for the Sony Z5. It's a damn good phone. Then he told me something very interesting. Sir, you bought the HTC phone now. Tomorrow, if you come with the same HTC phone, I'll not give you more than 1,500. How do you like that, Arvind? Of course, he must have been, maybe he was joking, but I think you understand what's happening in the market, no?
Yes, sir.
In a very turbulent industry, like the mobile phone industry, turbulent in the sense that very fast changing, you know. So the value of the goods starts depreciating very fast. I think you understand depreciation. It's not that you've actually spent that money. I hope you understand this. Depreciation doesn't mean you spent that money. Let's say I bought the Sony Z5 for whatever price it was. I'm just giving you 15,000, and I get 1,500 next year. Doesn't mean 13,500 I've spent. That value of the phone has gone down, that's all. Okay. So equipment, now you can understand. Similarly, even in industrial equipment, there is depreciation, which is a part of your balance sheet also. The depreciation figures go into your balance sheet in some way or the other. Okay. I mean, they'll be there. Okay. So now answer the question, will your equipment acquisition cost still remain your original cost in the denominator if you are calculating maintenance cost over the year?
No, sir.
Yeah. So it depends on what accounting philosophy you want to use. Okay. By the way, I'm not a finance expert. You should talk to somebody who's an expert on finance. I'm not, but I can tell you that depreciation is real and it is a part of accounting practice, and the equipment value will drop after a year or two. So it's not fair to use the original equipment acquisition cost for the second year of maintenance operations. It may not be very correct. Have you understood this, please?
Yes, sir.
Yeah.
Yes, sir.
Okay. So we'll stop with this for today and then continue tomorrow. So tomorrow 9 o'clock. Bye, guys.